Okay, let's go on with the calculation of depth for FIFO. The unity of FIFO is usually used to smooth out the data bound-wise mismatch within a short time between block A and block B. So let's understand the unit from an example. For example, we assume the clock frequency is 100 MHz, and for every 100 clock cycles after reset, block A will calculate something and cycle 0 to 95 and write out 4 results at cycle 96 to 99. Yeah, that is for block A. It will do calculation for 0 and then it will output data, output 4 data in 4 cycles. Then it will repeat this behavior for every 100 cycles. Yeah. Okay. It will repeat. And for block B, it will consume a data for every 25 cycles. So this is block B. It will use one data in this time, and it will use another data in this time. Yeah. And block A will transfer data to block B. So if you use Handshake interface to click them directly, there must be wait cycles for block A. For block A, for example, in this period, the ACK signal must be assert low for many cycles. Yes, so this will extend the cycle used by clock A to output the result. So the whole time for the whole cycles used by block A to process a block of data will be more than 100 cycles. That will lower the performance of block A and block B. Yes. So one solution is we can use a FIFO between them. Yes, we can use a FIFO between them. We can use a FIFO. So the FIFO is used to smooth out the data bound-wise mismatch within a short time. For here, the short time is 100 cycles. For 100 cycles, block A will produce 4 data and block B will consume 4 data. Yes. So from the view of 100 cycles, the data bound-wise for block A and block B is equal. But for a short period, for a very short period, such as for the 4 cycles, the data bound-wise for block A and block B is not equal. Block A is much higher than block B. So we can add a FIFO between the 2 blocks to smooth out the data bound-wise mismatch. Okay, so this is the usage of FIFO. And return back to the question. When we use a FIFO, yeah, when we use the FIFO between them, how to design the depth for the FIFO? You can choose 2, 3, 4, 5. How to choose the depth for this FIFO and this application? Can you calculate it? Yes. As for design, we have the PPA concern. we want to save the area. So we just use the minimal depth that can smooth out the boundwise mismatch. We want to find the minimum FIFO depth number for this application. So if we want block B doesn't hold block A when it's writing out results, what's the FIFO depth? Can you calculate it? Okay, you can pause the video and I will go on. Okay, the answer is the depth is equal to 4. You can draw a timeline to calculate this number. Yeah, the timeline that I have drawn before. Yes. You can draw a timeline something like that. Okay, one more question. If we change the situation, block B can consume data for every 15 cycles, and block A will output for data for every 100 cycles. For this situation, if we add a FIFO between them, can we have the effect of block B will never block A when they are working? So you can say at this situation the boundwidth is mismatched from a long-term view. The boundwidth of block A is higher, is 2 times that of block B. So whatever the depth of FIFO you have designed, block B must block A at some times. Okay, one more question for the depth calculation for synchronous FIFO. The question here is: assume clock is 100 MHz and block A will write out 50 data for every 100 cycles and random cycle time, and block B can consume 1 data for every 2 cycles. So the question is, if we don't want block B to halt block A when it's writing out data, what's the minimum depth for this FIFO? Can you calculate it? Yeah, block A will write 50 data for every 100 cycle and random cycles. That is, we can't predict when it will write out data, but we can sure it will only write 50 data for every 100 cycles. Okay, let's analyze this question. So let's first find the peak data write out boundwidth. If block A write out 50 data and cycle 50 to 99, yeah, this will be the peak write out boundwidth. For the last 50 cycles, it will write out 50 data, low weight cycles for the last 50 cycles. And in this period, block B can read out only 25 data. So you can calculate the depth of the FIFO. 50 minus 25 equals 25. So we have the depth of 25 for a FIFO. And there is one question. Can we design a FIFO of depth equal to 25? Or you can say, can we design a FIFO of any data bytes? For example, 1 to n depth. Yeah, when you when you consider the question, you have to think about how to design the behavior of the 2 pointers. If the FIFO depth is not equal to nth power of 2, how to define the behavior of the 2 pointers and how to generate the full and empty signals. Okay. Okay, there is a word trick for this question. A word trick. If we explain the question as if we explain the question as this time format, that is 50 data output back to head. So the peak boundwise will be block A will write out 100 cycles in 100 cycles. So if we explain the question in this time format, so the 5 depths will be 40. Yes. Or you can see, if you give the figure in this format, you have to change the question. You have to change the question to block A will write out 100 data for every 200 cycles. Yeah. Okay, you can say that this is just a trick of word, but it gives us a hint that when calculate the depth for FIFO, you have to find the peak difference of consumer and producer. And in some applications, there is no need for you to smooth out all the boundwise mismatch between block B and block A. That is, for some applications, it's allowed for you to give a small depth of FIFO and block B may halt block A at some times. This is also acceptable according to your performance requirement. And we can see the bigger the depth of the FIFO is, the FIFO will has bigger ability to smooth out the boundwise mismatch between block A and block B. Okay, there is some small questions for you. Can you design a 32-bit wireless and 8-depth FIFO and write test bench to verify their function? And I have assigned this question in the course. And also, can you define a more general synchronous FIFO? That is, the data wireless and FIFO depth can be configured when the FIFO is instanced. Yeah, what Verilog construct you will use to achieve this function? Okay, that's all for this section. Thank you.